Hello guys, my name is Dylan, my YouTube channel is DRG Bros, and today we are going to be doing a review of Calculus 1 Proportionality. So topic 1 is going to be our review, and this is quite quick. So we're just going to review over the bridge of mathematics. So, and there's two groups of this. So there's arithmetic, algebra, and trigonometry, which fall under the finite number of steps, which means there's a certain amount of steps that you have to do, or amount of possibilities of steps that you can do. And then we have calculus and higher ideas that we're going to explore later. And so these are infinite processes, which means there's an infinite amount of ways to solve them. It's just infinite. So now we're going to move on to topic 2, which is direct proportionality. So these are correlated qualities. So let's say we have a little kid walking down a road. And let's say he was going at an even pace. And then we have a little observer who is observing what he is doing and making notes of it. So this is like an experiment. So what we can say is that the distance is directly proportional to the time. So the distance he travels is proportional to the time it takes. And so the distance is equal to the constant time. We use a K because it's tradition here. And then here we can say D, or distance, equals rate of time. And there we go. We just found a direct proportionality. What we can also do is we can say, let's have our guy up here, and then we have our observer, and the guy is throwing rocks down a cliff side. So what we could say is that the velocity is directly proportionate, which we use an omega, or an alpha symbol, to time. So the velocity is equal to the constant time. So the velocity is equal to gt. G in this case is special, where it stands for 9.8 meters per second squared. So now we can move on to our next example, which is the same image. So we have our little guy dropping rocks, and we have our observer watching him as he throws the rocks. And so here we can determine that you can say that it's distance is directly proportionate to time. Now this only holds for a very, very short time. And when I say short time, I mean milliseconds, where it is traveling at the exact speed. So a better representation is if we square this. So we know that this is distance equals constant time squared, which will then equal the distance equal 1/2 of gravity time squared. There we go. For our final example of this topic, we have our little guy here and our observer. And what he's doing is he's drawing circles with different sizes. So what we can say is that the circumference is directly proportionate to the diameter. Equals KD. And so what we replace this with is actually pi. And it looks like this. Okay. Next and last, I would like to talk about inverse proportionality. So let's say we have our guy with a teeter-totter and our observer. Let's call this side D1 and let's call this side D2. If our guy pushes down on D1, then D2 will move up. That is basically the entire point of inverse proportionality. Where direct proportionality, both things would increase. Here, one increases and the other decreases, So if you do, one of them will decrease or increase the other, while decreasing or increasing itself based off of what's happening. In this example, what's happening is he is pushing force on D1, which will make D2 rise. But if he was pushing down on D2, D1 would rise. So we can also say this. D1 is proportional to 1 over D2. So D1 is equal to the constant 1 over D2. So D1, therefore, is equal to L 1 over D2. Next, we have our observer, and what he is doing is he is observing our guy, and our guy is attempting to move these boxes right here over to, let's say, an unknown location, which could be over here, let's say. But what we want to figure out is how much will the time increase if we add more people. So we have T 1 over N. So T is direct proportional to the constant 1 over N, which means that the time is equal to the people 1 over N. And then lastly, we have our guy who is watching some TV. And then we have our observer. So what we have is the intensity of the sound is proportionate to 1 over the range. thank you guys for watching. I hope you enjoyed this video, and I hope you learned. And I will see you next video. Bye.